How you doing? Excellent. Good answer. I like that. So welcome to Architecting for a Secure Cloud. We have a lot to talk about. Everybody do this. What hat are you wearing? I'll give you a clue. The architect's hat, right? Okay. So what we're going to be doing is talking about the cloud from a perspective of security issues. But in order to do that, we need to think a little bit about why we go to the cloud and why we would bother putting anything in the cloud, right? And therefore, what are the concerns we would have from many levels? And I think that starts with the CIO level all the way into the architecture plan and then down to development, right? So for the developer in you get to look at code samples later that I have already posted. And for the CIO in you, we'll talk a little bit about that. And you can look at some service level documents and capacity planning things I've already posted in previous talks on my blog. And for the architect in you, what are we going to do? Listen up, right? So, lots to cover. My name is Michelle LaRue Bustamante. I'm an architect for the past 10 or so years with iDesign. We do high-end architecture consulting. So I visit a lot of different customers for many different types of application architectures from all these years, focusing mostly on WCF, identity and security aspects of the back end, as well as the technologies that talk from the client side and how do we secure that as well. And lately, of course, cloud computing has been one of my areas of focus. So that's what we do. I'm also a partner in a business called Bitku. We build identity and access management software. So that's where I spend a lot of my time as well. I spend a little time on security, I guess. And in my spare time, what's that? I do a lot of other things, various things. I write articles, and I have some CodePlex sites with utilities that you might find useful for WCF. And I'm a MVP for Connected Systems and a regional director. That means I don't work for Microsoft, but I do have the honor of frequently working with product teams in my areas of expertise and try to give back to the community. If you want to find out more about us as a group, there's many regional directors speaking here. Go to theregion.com. But MichelleLaRueBustamante.com is where I post stuff from conferences and code samples when I have them and update them. So there's a lot of stuff already up there related to WCF and identity and cloud. You want to maybe check that out as well. And then after the conference, I always make a post with links that are useful from the session that will augment that. So just keep an eye out for that as well, okay? So what we're going to do is talk about why we would go to the cloud briefly, but really just to set context. And, it's probably a little more than just, to say that we're using the word cloud in a conversation in a meeting, right? And then I'll briefly touch on the IT and shared hosting aspect, but mostly I want to focus on application architecture issues because that's why we're here. It helps to just at least briefly discuss the various other items as well. So what drives us to the cloud? There's a lot of reasons why we might use a cloud vendor. Of course, this is nothing new, right? Back in late 1999, let's say, people started building application service providers, right? ASPs, which became later known as software as a service, and now it's just called cloud as a general umbrella. And when we had to do that back in the day, one of the things we had to do is prove to our customers why they should use our service, because how can we show that we can be a 24/7 operation, and how do we know we can really scale, and how big is that iron behind the firewall that hosts the data as well as the application? And if I send you 100,000 requests today, which by the way never happens, they all think they're going to do that and they don't, how do I know you can scale that? And what about our peak periods, 4 times a year and so forth? So these are the types of issues customers have. It's important to know that you can handle those things, but it was really hard to prove back in the day, right? And that was because not a lot of people really knew how to host and be reliable and scalable and, of course, secure on top of that. In fact, back in those days, I can recall going to sessions where I would see people talk about how insecure SOAP made the network, just as a general conversation piece. And it was not actually accurate. It was just, somebody being a little bit disruptive perhaps in a meeting, but you know what? CIOs listen to that. So it was difficult back then. We had to invest a lot of capital up front in order to show that we could scale, and now guess what? We don't have to do that, right? You can scale out as you need to, you can add machines as you need, you can roll back or scale back as you need to, you can handle burst and peak loads. not automatically. You need a little planning. You have to have customers give you a little information about the load they're going to bring to you and where are their peak periods. Otherwise, how do you hit the button, right? But really, ultimately, the point is to know where is the button I need to hit when something happens. In fact, that's the number one thing you can take away from any session about how to do a good job in the cloud, right? Or how to be a good host in general, even not in the cloud. I need to know where the buttons are to hit when things go wrong, when I need more scale, when something breaches, or so on, okay? Now, what this allows us to do is get an overall IT management strategy that's a little bit easier. That doesn't mean reducing headcount necessarily, because we're usually short on that anyway. It's more like repurposing the headcount so that maybe we actually have the time to document and plan processes around the issues like the what ifs and build our own internal service level agreements that actually explain how we know we're secure and how we know we scale and how we know the vendor we're using makes that possible. Because we still have to know all the things we had to know when we hosted it ourselves. We just don't have to do all the work. We still have to document it, know it, understand it, and know where the button is, right? Certainly what we're hoping for is that cloud providers like Microsoft have been around the block on this, and they know maybe a little better than us how to host a 24/7 operation and recover, because that's their 100% core business. And I would argue that's a pretty safe bet, but we still have to know where the button is. And ultimately, why do we like this? Because then we can focus on business logic, right? We want to build apps, and we want to ship them, and we want to make lots of money. So that's how we do that. We don't spend time on things that are commoditizable, if that's a word. So the typical concerns that come with the cloud then is, of course, oh my God, now I have no control, right? It's not really true. It's just that you need to have a sense of, where's my stuff? What did I deploy up there? If something went wrong, how do I redeploy that thing? Where is my data? How do I recover if something went wrong? Do I trust that they've got backups, or do I do my own? Of course I do my own, right? I mean, these are the things we have to know to make sure we don't feel that loss of control, so that we can put faith in the reliability of the services. We want to be able to know what the service level commitments are of the vendor. That's always a big topic, right? There's some pretty good service level agreements up there today, I'd say. In the past, I remember seeing one-pagers in the late 90s that pretty much promised nothing. And I'd say there's some pretty good guarantees of uptime and failover and recovery, and those are the types of things you want to look for in a service level doc. I'm not going to spend a lot of time on that, but I do have a sample service level agreement that comes from, you know, sort of way back things, and I repurposed it and I posted it recently, just as an example for people how you might write an internal service level doc that helps you understand, how do I scale? How do I know the provider's doing, you know, what they're supposed to be doing? What are the things I should look for in a checklist that I should somehow be able to explain, either we're doing that or the vendor's doing that? You see what I mean? So take a look at that offline. If you want to change vendors, if something goes wrong, you may need to have a strategy around that. Sometimes that's another issue to think about. And then ultimately security, right? Security's the number one thing people worry about when they feel a loss of control, when they start putting things and trusting them to a vendor. And that's where we're going to spend the time today, right? So the building blocks that we're looking at when we talk security, right, are several. Obviously, underneath it all is a platform infrastructure equipment, actual physical data center, and that is what hosts all the Azure assets. So we've got, you know, Azure Storage and SQL Azure. We've got Windows Azure, and then, of course, the infrastructure services of App Fabric. So everything's based on the same infrastructure and data center, and the reason I point that out is because what we're looking for is how do I focus on the IT considerations. This is not the focus of our session, but important for you to know that part of the complete story of security is also a lot of these physical data center concerns that need to be documented. I have to have that checklist that says, I know the provider does these things for me, and this is the stuff we have to do. It's no different than what you would have to do if you hosted it yourself. You still have to know. It's just you don't have to do it all. So if you look at this slide here, it just summarizes all the stuff your provider is really giving you, you know, to take care of the data center aspect. It's a world-class data center. Microsoft's kind of been doing this for a long time. as has Amazon and other providers. But the point being, you can rely on this being done for you. You're going to have physical access secured to actually enter the facility, right? Not just anybody gets to walk in. There's usually handprint readers and all kinds of interesting things. They're controlling how administrators access the physical equipment, right? So somebody can log into those boxes that you're using, but not too many people, right? They've got that under control. You don't have to be, too anal about those details, but you do need to understand, yes, those things are covered, right? So if I was writing a service level doc, I'd sort of have these as bullet points, and I'd try to explain, I know this is covered, right? Patch management, virus scanner, all the things that are pain to do when you're actually, deploying software and having to manage that upkeep. We don't have to do some of those things, right? They're going to make sure that when they upgrade the machines and add maybe patch the OS, that it's backward compatible before they deploy that out to the SQL Azure platform, right? And they do state that actually in the documentation. So some of the links I'll provide you to Global Foundation Services, for example, that describes a lot of those security aspects and a lot of their process. So then it really comes to what do we have to do? From an IT perspective, what we care about is if I have remote VM access or I have accounts that I manage my cloud instance from, which is the portal I log into, I better lock that account down very carefully, right? Because that's the magic account, the MSDN account, whatever, that gets me access to the portal. So protect that, make sure it's not written down anywhere. It's in a piece of paper below a dungeon with a fire-breathing dragon on top, that whole thing, right? So IT stuff is covered. Shared hosting is another concern people often ask about, just to briefly touch on it. Obviously, you want to make sure your database instances are physically separated. They take care of that. Packet filtering to make sure messages are getting to the right VMs and so forth. They take care of that. They're looking for malicious, tenants. So, VMs behaving badly can't affect your cloud instance, your VM, because it's limited amount of memory that you have access to anyways. It's a limited amount of CPU power. It's a limited amount of disk access. So you can't bring another VM down. And if you're shown to be behaving badly, guess what? Your account gets locked out, and you don't get to be a VM in Azure anymore. And there have been instances where people have been revoked. So that's just something you should know, that the network access is being controlled and so forth. So that leaves what are the things we care about. If I allow remote entry into the VM, because that's one of the newer features, right, on the CTP, then I obviously need to manage that carefully, because that's somebody getting access to my machine. So make sure you're protecting that process. That's all you, but everything else is covered. So let's move on to application architecture, because this is really where we're focusing the rest of this discussion today. And there's a lot of stuff to talk about, right? Transfer security, encryption, key and identity management, access control, architectural aspects like how I'm designing my system with the DMZ or other vertical tiers, for example. And then there's risk assessment, which is really you looking at each asset you'll put in the cloud, primarily thinking about data and content, and what the risks are to your company, to your business, and what any legislative or legal requirements are for that data and or content not maybe leaving a region geographically and things such as that. There are some instances where you simply can't put data in the cloud, for example. So you need to know that about your business before you go forward and then decide which assets you can put in the cloud and leverage, right? So that's something that you'll establish as a business. So let's move forward and talk about the features that we're going to discuss security around. So Windows Azure Platform has a lot of moving parts, obviously. In Windows Azure, we've got the web and worker role, for example. These would be our VMs that it could be on one VM or separate VMs, but basically the idea being I've got web applications and WCF services and things like that. We'll talk a little bit more about those as I expand into the depth of the talk. There's Azure Storage, and in Azure Storage, of course, I have queues, tables, and blobs that I can access through a REST-based interface. So that's supporting my Azure application, right? And then I've got SQL Azure, which would be my relational data store. So we're going to talk about that. And then I've got App Fabric, which gives me several features, right? I've got the idea of perhaps calling services that live on the corporate domain and safely exposing those using the service bus as a DMZ, for example. So we'll talk about that. And then there's the cache, right, which allows us to have cache in the cloud and then also in IIS 7.5, right? And then we have access control, which is where we get our identity federation features with perhaps ADFS v2 on the corporate domain if we're using domain joining, which is the newer CTP feature, and or to another STS somewhere. And so we'll talk about those scenarios too. Okay? So we're going to go through a lot of stuff. You ready? I'll take silence as acceptance. So service bus, we'll start with that. Something simple, easy to discuss. What is it for? The purpose of the service bus primarily is to allow you to safely access on-premise, behind firewall, private IP addresses with a DMZ that would be placed in the cloud that gives you denial of service prevention and also security if you add on the symmetric key authentication. So we'll talk about that. Now, it's got other features, right? Because of that, I can do things like callbacks to client applications. I can do other types of messaging and notification features. There's new features forthcoming CTP-wise that you've probably seen sessions on already. So the point is, it's an on-premise service primarily, or maybe on a client box that's difficult to get out to the network. We leverage the service bus so that it can be accessed, but safely, okay? It's probably one of the most used features of Azure in the sense that it's got such an immediate gain to companies. I deal with a lot of architectures from a consulting perspective, and this is one of the first pieces that people tend to go for. It gives you some essence of reliability and scalability in the sense that we get denial of service prevention in the service bus tier. So we'll talk about that architecturally shortly. And then it gives you some extra security. So let's first look at some reasons why I might architecturally position the service bus and how that might look in the various technologies we use from a client perspective. So imagine I've got a web app that's built on MVC. The MVC site is obviously hosted probably in my DMZ then, assuming I haven't put all that in the cloud too. So we're just focusing on one thing for now, service bus. So when I call a service behind the second firewall, which is behind the DMZ, which is usually where I put my enterprise business services to protect them, I have a way to do that from the MVC site, right? Somebody's interacting with the page, they click a button, it goes to the page, and then that page calls behind the DMZ. We've got some level of trusted subsystem authentication there, so I've got some sort of Windows account or certificate calling that service to ensure it's safely exposed. But what happens if I have jQuery, I have AJAX in the site, and it needs to call back to do some stuff? Well, MVC is kind of a special case, right? Because you've got the MVC controllers that can act also as REST endpoints, right? So I could provide a subset of functionality right there in the DMZ tier and then have that call back to the service, no? So we've got a good architecture already here that probably doesn't need a lot of change. Similarly, I might have a ASP.NET Classic Web Form site with some AJAX in the client browser, and then that would, of course, then need some way to call back to those services to do work, right? If I have any AJAX, late loading and or asynchronous calls. I can do that by standing up a WCF REST-based endpoint. Since I'm not in MVC, I don't get the controller aspect. I'm not going to probably mix those. It's one or the other. So fine, I've now got an architectural solution for that that seems fair. A subset of functionality just for the AJAX page, no problem. But what happens when we move to some of these richer clients? So Windows Phone, for example, I'm probably going to have a subset of functionality, but it can do a regular service call back to the business logic, and it's not having to be async, and REST is probably a good choice for that, but what would I have to do? I'd probably stand up a REST-based endpoint with some reduced contract for the WCF service, right? And now I've got my DMZ hook to get back to those services behind the firewall, right? WPF is a little bit more interesting, because normally when I see this architecture, we don't want to produce another service in the DMZ that does exactly what the service behind the firewall does. So since it's not a subset of functionality, what do? Well, I can use a router then. So then I guess I've still got a stopgap, right, to get back to the DMZ. I can still do trusted subsystem to make a call from the DMZ to the services behind, and that works. But it's starting to look complicated, because what if I have a lot of these things, moving parts, right? I want to standardize on one thing if I can. So it's starting to feel dirty, not right. Same with Silverlight. Silverlight can usually call a pretty rich interface. Doesn't have to be a subset of functionality. But typically, we do like REST a little bit more than we do SOAP from Silverlight. It's favorable. We could go the either route. We could have either a REST-based service as a shim, or we could do a router. My point is, we're trying to get back to services behind the DMZ safely. And we're controlling that with trusted subsystem model. These three on the right, though, in a way I'm having to create an extra thing just to get back there, whereas with the two on the left, you might say, well, that's a sound architecture anyways, because it's how many AJAX calls really need to go back to the DMZ that then subsequently call the service, right? I'm not reproducing the whole service real estate there. So I could fix that by just using the service bus, because now I've got my DMZ, and I'm just calling the service directly. And now if I need to, I can expose certainly different endpoints, either REST or SOAP, a subset of functionality for Windows Phone, for example, if we don't need the whole set of functionality, or if we need different data contracts, perhaps, different type of payload, reduced payload, more efficient, that kind of thing. So this starts to look nice, right? You might even argue that if I didn't have a DMZ at all, my network is safer. So if I could get those web apps up to the cloud and not have the DMZ and not need to manage the DMZ and not need to hire the expertise to make sure that that DMZ is safe and secure and use the cloud for that, then I might be in better shape. So something to consider in terms of why the service bus is important and useful. Another reason it's very useful, though, is oftentimes I see customers that are moving to the cloud the actual application, but they need to migrate. They can't just move everything tomorrow. They're actually putting new features in the cloud, slowly migrating old features. So what they have is maybe data that lives on the corporate domain with already services working and functioning fine. And what they want to do is just make that thing available to their new functionality that they put in the cloud, which they can do by putting in Azure the web application and then having a service bus endpoint for the service. And another value add to that, of course, is what if that data can never leave the corporate domain? Well, now I've got a way to get to it, right? Okay. So these are reasons why service bus matters. It gives you a view of some architectural points, but really what we want to do is move to the security aspects. So I've touched on this already. We get the DMZ and denial of service prevention at the cloud tier, right? Because that's provided by the service bus. And then we've got other things we need to think about from an app perspective that are kind of under our control, but we need to know how to do that with service bus. So how do we get transfer security? How do we get authentication? And how do we handle key management? So looking at this, if we have a client calling service bus endpoint, what you don't see happening is we've got this proxy at the client that's using a WCF binding, that's a relay binding, which automatically handles first calling access control to get a token that's legitimately allowed to call the service bus endpoint. I'm assuming, of course, that I'm putting out there a service bus endpoint that requires relay authentication. And I would suggest that's a good idea, so why not? So we're going to call access control. We're going to pass a signed request, so we need a key, right, to prove that we're allowed to call access control and request that token. And that means that we're managing a symmetric key at the client, and then, of course, access control has the symmetric key for the service bus endpoint. So we need to share that key. And we need to protect that key, which we'll talk about. And then we've got the token being returned back, but we don't really see that. It's passed safely back over HTTPS, so we need transfer protection. It's forced through HTTPS on that endpoint. And then we call the service bus passing that token plus the message that we would have sent anyways to the service. Ultimately, the service doesn't really know about all that token exchange, right? So if you say, I want a secure service bus endpoint, you don't actually need to mess with the token at your service. It's handled by the plumbing. So your binding says, okay, this is a relay binding that requires authentication. The cloud listener enforces that, and then the client binding does the same. Okay? So what your takeaway here right now is, okay, we've got this transfer security from HTTPS and or TCP on the, calling my service side. So we're not going to have man-in-the-middle attacks there. And then we've got this symmetric key that we can use to add a layer of security to calling the service bus. And then we've got this hidden endpoint. The service endpoint's never exposed. That's one of the value propositions of service bus. You don't get to call that service endpoint directly. It's only available if you go through the service bus endpoint in the cloud, which means if you secure that, you can't even make a call to that unless you have the key, right? Now, because we may want to encrypt data all the way through to our service, even though I do trust the service bus to not inspect that packet, even though it's going to decrypt and then re-encrypt when it calls down to my service. So I get transfer protection point to point, right? Client to service bus and then service bus to my service. But if there's another proxy in the middle there or another intermediary somewhere in there, or a proxy server at the client, then we may want to encrypt all the way through. And so we can still do that with message security with WCF. So that'll just pass through as an encrypted message, and then it's received as encrypted at the service, and then using your classic WCF bindings, you get your message encryption. So you can kick this up a notch by turning on message encryption, okay? Message security. And then your evil clients don't get to call. And even if they did, there's another layer of security on here that we haven't considered, and that is there's probably still an authentication token in there somewhere, right? Calling the service bus is just, hey, get me to that service. We're still passing, probably in the message, some sort of credential to authenticate to the actual service. So we'll talk about that a little bit later. So your takeaway here, and just a summary to try and sort of bring it together, you should probably require relay credential because that's more secure. You should encrypt your keys at the client, which means you need to do something to encrypt the symmetric key in the client config. I have an RSA symmetric key utility that I'm going to be posting that will support that for you. So I think that that's pretty straightforward stuff. You don't have to use DP-API. You can use RSA. That's probably better because then you can put that in the cloud more easily. You want to try to use TCP relay because that will save you money because you can get direct connect through the service bus. That's more of a technical detail. You want to add message security if it's highly sensitive data and or something that needs high element of auditing, for example, governmental financial institutes, for example, might require another layer of security. And then lastly, use negotiation. That just means I shouldn't have to provision the certificate at the service to the client. So that way, if we change the certificate at the service, it can negotiate a new credential for the message encryption piece. Okay? So there's your summary. How are we doing? Are you with me? Okay. Yes. 2 people are. That's good. It's a good average. So SQL Azure, moving along. Let's talk about the relational data store in the cloud first. So why do we do this? Usually because we need relational data. And we won't get into the details of why I would choose SQL Azure versus Azure Table Storage, but there's a wonderful white paper written recently by Andrew Brust, my friend, and that link is going in the post for the session, so you can find that easily. Okay? We'll help you make some decisions like that. At any rate, when you have SQL Azure, what you have is a SQL Server 2008 R2 in the cloud. So it really doesn't operate any differently than what you would normally do on-premise, except that there are certainly some security considerations we need to talk about. You're still going to have TDS support for client connections, management tools. You're still going to, well, you're going to have an added value of a REST-based API, which is awesome because it has certificate security. You're going to have firewall rules, typical SQL Server authentication, but not Windows. And then the certificate authentication is for REST-based. So let's just sort of explore that a little bit. Typical reason I would use SQL Azure is because I probably have a Windows Azure hosted app that's calling data. There's probably not a lot of reasons for me to put just data in the cloud. My cloud story would usually be the other way around, if anything. My data has to stay on-premise, but I want my app in the cloud. But if I am in the cloud with my app, and I'm all in cloud, then I may as well use SQL Azure in the cloud as well for my relational store, as long as I don't have any federal restrictions around that, regional geographic restrictions. And a question?
Yeah, you mentioned it doesn't support Windows authentication.
Yeah.
Would it support delegated Kerberos? It doesn't sound like it would.
That would be kind of Windows, right?
Yeah.
So I'm going to say no.
Because a lot of times on requires all.
Yes, I see what you're saying. So the question is around auditing in the database. So SQL obviously can, I have this discussion with customers a lot because they want to use a Windows account for the auditing, but it's user level. And that's just kind of bad anyway, because now you're managing how many users, right, that maybe call the system to authenticate to call services, and then you're delegating that credential all the way down. And yes, you're getting an audit trail for free, but what you're also doing is diluting your connection pooling capabilities and such. So it's actually a performance hit depending how many users you have. Generally speaking, trusted subsystem is a better model, but then you have to come up with your own auditing. So you would be auditing because you have tables that also store who was the user that made this call. And that's really, I think that's the way to go anyways. So I don't think we lose anything in that case going to the cloud. Okay. So the web or worker role that you have in Windows Azure then would just communicate with SQL Azure, and that would be a typical scenario. But you may also combine that with services exposed to the service bus that have on-premise data that wasn't able to go to the cloud. So you might have a combination of these things. It's possible. And that would be the model that I would use for that. The point is just to get a sense of why would I use this and where does it fit, and then we can talk about the security aspects, right? So here, let's just kind of go through that. Now, there's some IT aspects that you should just kind of keep in context here, which is why I put these little tables together. You're going to think about things like, well, customers like it when there's a physical server separation. So, you are the customer in this case. You get that. But you also need to think yourself about database instance isolation for your customers that use your service, right? You may need to keep instances separate for each of your groups of customers in some cases, if you can't prove to them that identities are good enough for separation. And everybody's got a different story there. Backups. Yes, there are triple replicated backups, but you still need to be able to replay your data. So you have to still manage your backups like you would on premise. And guess what? You have to actually test that. Because if you don't, you might find out it didn't work when you tried to replay the logs. And I'm not saying I've ever been there, but let's just say in 1999 or so, we did encounter a situation, and luckily it was before anything went wrong. Backup and recover, very important, and you do it, and you test it. So, retention. Some people care about how long is the data kept in the cloud if we sever our ties. 90 days is the answer. Geographic restrictions. You can set the data to be in a particular region. What you can't control, though, is, well, if you have code accessing that data, could it be leaving the region? Could it be leaving the state or the country? And if you have restrictions like that, sometimes you don't have an option to put things in the cloud and or expose it on the internet at all. So that's just something for you to know about your business. And then, of course, the remaining items here are the stuff we're going to talk about from an application perspective. How do we control administrative firewall rules, users, and so forth? So let's go through that. Azure security, if we take a look at just a simple example. I've got a master table, of course, and I've got maybe a couple other tables that are supported by the application. A lot of times I like to call my tables A and B just because it's really clear what the purpose of the table is, and so I find that useful. The firewall rules, what? So the firewall rules are there to protect you as well. So where we might start out is in the web portal. The web portal, I have this account that I need to protect with my life because that's the one that lets you log in and set up shop across all of your Azure properties. This is the one that you're going to use to probably, this one has access to all the tables. You could use that account and you could go to, SQL Management Studio and start having fun. But if you share that account with anybody, that's probably not good. So you just keep that admin password to yourself. Go ahead and create a new user login in your master table. Go ahead and create a user in the other tables for, those that you allow this account to administer. And then now you've got an account you can give to your DBAs or whomever to set up tables and configure things, okay? So you're going to start out with that. And then you're going to create accounts for what I would call the trusted subsystem model again. So just like I would do if I wasn't in SQL Azure, I'm going to have a user account or role for certain groups of services, for example. These services are allowed access to this table. So table A is allowed to be called by that service in the corporate domain. So it uses that account. Plus, we have a firewall rule around the IP address. So you also can't just call it from anywhere. It's got to have the right IP, and it's got to have the credential. So I've got my trusted subsystem with 2 layers of protection. I'm going to create another account maybe for table B, and that would be called maybe from some other service. Maybe it's hosted in Azure. Again, either way you can go. The point being, I create the credentials like I would with any SQL deployment, which is trusted subsystem. These group of services get these tables. This group get those. The reporting services get those. And we separate the accounts that way. But it's not an audit trail of individual user access. You have to handle that. And then, in terms of access from an IP address perspective, you have to check the box Allow Microsoft Services if you want your Azure account to be able to call into your SQL database, firewall. Firewall rule is 000 to 000, something like that. And then we might create another account that is granting access, for example, to other services. AS, which I won't say as a word, is really SSAS, right? So we've got reporting services and integration services, and then we've got, sorry, I'm just totally, analysis, thank you, BI, right? So it really should say BI and SSAS. But there's only one S there, so it's OK. We're safe. So there's also one other aspect of security, and that is the REST API. So the REST API is pretty cool because we can use a certificate to authenticate, which we can't do from the SQL administrative side. And we can use that to actually generate firewall rules and control all kinds of things. So that would be the direction I would try to go in terms of managing my SQL deployment, if I could. So it just means spending a little time on that. Okay? And you're going to have, obviously, a public key that's uploaded that you've set up as your trust. And that key's got to be protected also with the fire-breathing dragon. Same thing. Okay? So summary of recommendations on this aspect. You're going to use the portal admin, right, to create database accounts that are allowed to administer. Don't ever share that portal admin account anywhere else, right? You're going to have DB admin accounts that do the schema and the user configurations for the deployment. And then you're going to have the trusted subsystem accounts for calling from services. And you're going to try to automate with the REST API. Good recommendations. Okay. What about protection of data, though? What if I need data to be hashed or encrypted? How do we handle that? Well, that's not for free. So that's just kind of how you would have to do it anyway. So we get into key management and key material protection. So taking an example, if I wanted to encrypt data that I'm going to save into my SQL Azure store in the cloud, then I would need to encrypt it before I send it up. Okay? Not really rocket scientist there. I need to have, probably I'm going to use private public key encryption. So that would be asymmetric encryption, a little bit stronger than symmetric key. And I'm going to need to have the private key available to the same and or different service, whoever's going to do the decryption. So I got to protect those keys. They could be protected in the cert store of wherever the service is hosted, whether it be in Azure or whether it be in on-premise, corporate domain. What about hashing, like a password, user input? They give you a password. You usually hash the password in the database, typical common thing to do. You got to still do that, which means you're going to have key material to do the hashing that needs to be protected. And you're ultimately going to use that to do a comparison when it comes out. So nothing of this is special or new. It's just something else we have to consider, and we still do ourselves, right? The important thing is protect the keys in the sense of the key material for the hashing. You're going to need to protect that information in your web config or app config, wherever that is. So try not to ship that out to remote clients, right? The rule of thumb is keep it at the service tier so you can manage it, so you can roll the keys, so you can roll the material, and you don't actually have to go out to your customers to make a change. Right? And that's where that RSA encryption utility that I told you about will come in handy. It's just simple, right? Encrypt the web config section. Done. So recommendations number 2 then, limit access to the hashing and key material. Makes sense, right? Duh. Use asymmetric encryption to protect data, because that's stronger, more effective, and you can use the cert store. And then hashing material, use your encryption of the config. Good checklist, you're done, right? How are we doing again? Next topic. It's like a palette change, just checking in. Okay. So we're going to talk about Azure and Azure Storage now. Just first, as a quick summary and combination, obviously, Windows Azure with Azure Storage together give you your compute cycles, your storage capability, and some services for managing actually the deployments and so forth. You've got a host for your web applications and WCF services. So we'll talk about that. And then you've got non-relational tables, which can be useful in their own right. Remember the white paper I mentioned of Andrew's. So you're going to look at that link on my blog after, right? And then you've got queues and blob storage, which have their own individual uses. Now, you'll see some architectural diagrams that show some of these uses, so bear with me on that. We'll just kind of keep moving. But the point is, you can mix and match any of these features. Some of them have unique uses on their own, and some of them it's kind of an all-in proposition, right? So we're going to go through that. Now, just from a high level then, what we're looking at is Azure gives us the idea, again, of the web and worker roles where you can host your services and your web applications, and we'll go into more of what's in there in the following section. And then storage gives you queues, tables, and blobs accessible through a REST-based interface. So that's your simplest view on the architecture. I point that out because typically, even though it's not always required, you will use Azure Storage because you have services and applications in Azure, right? They kind of just go hand in hand. You may still have a relational database, but you may use the Azure aspects for things like queuing up items and or small amounts of partition data in the table storage. And it's not maybe the core data that's relational, but it's supporting information for the app, configuration data, who knows, right? And then you've got blobs, which have their own unique use. So we'll get into some of that. How we access that typically is through either the Storage Client API, right, which is the object model Microsoft gives us to code up and access each of those artifacts, which means we need to tell it the key material for authenticating to storage, so we'll talk about that. And or you can go directly against the REST URI, which again still requires key material. It's just that you'd have to spin up the authorization header yourself and all the HTTP love that goes with that. Okay? So those are your options. So before I look at architectures and security, just briefly again, it's going to have a lot of the same concerns when you look at Azure Storage as you would for relational table storage, because we still care about the same security aspects, right? From an IT perspective, we still care that there's physical server isolation, which we get. But what we also care about is how partitioning happens, which is now under our control, because we're the ones creating the containers and the tables and, obviously defining what those look like and how we isolate that for our customers if we need to. So, retention policy still 90 days. Geographic restrictions, same as I already discussed. And then the rest is the stuff we need to talk about now, which is things related to administration and secure access to these artifacts in storage. So far, just to recap, we talked about why to use the service bus and how to securely access it. We've talked about SQL Azure and, obviously where it fits, but more importantly, the many moving parts of security there in terms of users and accounts and certificates for the API. And now we're just moving to another layer, which is, okay, what if I'm accessing storage? What does the security model look like there when I'm making those calls? So I know where all the pieces are, right, and the best practices. So first of all, we still have the web portal, right? That special account we get to log in where I can generate the symmetric keys, for example, that are used for authenticating to storage. Okay, so there is a symmetric key we're going to be generating, and again, we can roll those keys, so there's some aspect there in terms of management, and we're using the portal administration login for that. And then we're going to use management tools possibly for additional creating the tables, managing the tables, perhaps looking at diagnostics output, things like that. So we're going to still need the symmetric key for that. So what's happening is we've got the symmetric key that's associated, and there's two keys, right? There's the current or primary and secondary key. When you roll the keys, the secondary moves to primary, so it gives you a way to configure your service and then do a roll and get that old key out of there, right? So it's just a process. So the idea is, again, management tools and all other clients actually need to have that symmetric key. So I think the one flaw here at the moment is that I can't spin up a different key for different types of clients and manage that. I have to have the key, which means I want to limit where that goes carefully, right? So I've got services maybe in Azure that are going to call and need to have the key. I'm going to have maybe corporate domain services that might call and need to have the key. And then maybe I'll have remote clients. Do we like that? Maybe not so much the remote client, right? Because now if you've got UIs on your desktop that need the key and we roll the key, what happens? Chaos, right? I could have said something stronger, but I didn't. So the symmetric key, important to protect. Maybe a better architecture would be that my services in the corporate domain or in the cloud are the ones that call the REST-based storage, and my remote clients never need to know about that key. Obviously much better, right? So that would be a better architecture. And that means when I roll the keys, it's under my control because I own that deployment. So it's a process we can go through ahead of time, use the secondary key, roll the key. Okay? And of course, we've got the usual need to encrypt the key, which is back to that RSA utility. If you've got a web config or an app config, there should be a way to hit a button, just encrypts the section, right? And not using DPAPI because that ties you to a machine and it's harder to manage in Azure, so therefore we use RSA, which means we have a private key, public key pair, right? So recommendations generally, never ship keys to non-owned clients because that means we got to deploy a new key when we roll, not good. Avoid shipping keys to remote clients at all, just because the same problem, really, even if you own the client, could still be a mess. And then lastly, encrypt your keys in the config. Okay? There's your checklist. What about blob storage? Well, there's some special things related to blob storage. One is integrity. There's actually a signature associated with blobs. So if I upload a large piece of media and or even a drive, which is much, much bigger, then I can use the MD5 hash that's created to validate that what I got back had the integrity that it should. Now, Azure already validates integrity when it saves to storage. So you'll get an error if it didn't work, and you could retry and replay. But if you're uploading really, really large blocks of data, and or if that data is so mission critical that you'd really be in a lot of hot water if something didn't work out, then you might want to check your signatures all the time so that you can tell a customer when, oh, you know what, there was a problem with that. So the MD5 hash is created when you save to the blob container, and it actually comes back when you request, so you can access that header, and then you can write some code to validate the hash. So I'm giving you a link to where you can go for that information so you can have a piece of code that works, right? So good to know that you can do that, and definitely for very large amounts of data, recommend it, especially if it's a drive, page blob, something like that, right? Okay. So recommendation for very large media, use MD5 hash validation. Okay. Next. Let's talk, oh, you know what? Would that be like, so if demos in an architecture scenario are slides, is that a bug? Read list. Wow, my demo just failed. Oops. So blobs have a few different ways they can be architected. We can have private containers, which by default means I need to use that symmetric key to do update, create, update, and delete activities, as well as reading and listing. Listing means I can look at the container and see a list of items. So I'd have to have a key in order to get all that information. And that also means, I'm not just going to the browser to do this because I need to pass the authorization header as part of the request. So it's a little more complicated than that, right? If we look at public container access, what that means is you're allowing people to list without passing the key. So in theory, you should not really allow that type of container access, but it is possible to do so. You could also allow read and list. So that's what public container access means. But anything related to updating, creating, and deleting would still be secured. And then there's just blob access, where you might want to let people read one item if you sent them the link without secure access, but you're not allowed to list, and you're not allowed to create and update and delete. It really depends what you're doing, what's acceptable here. I think as a general rule, I would avoid anything not secure. And there's actually another option you might look at for letting someone have access for a limited time that could be revoked. Love the word revoke, right? When we talk security, revoking is good, as needed. So service calls private container, and using the symmetric key, you do all the usual items, right? Create, update, delete, etc. But you can also create what's called a shared access policy. And with that policy, what you can get is generate keys with limited life, so that a browser, for example, can have a URL with a key and a signature, basically. And that shared access signature will give you access to that link, but for a limited time. In fact, less than an hour through the browser. You don't need the authorization header for that, so it's useful for links, just sending the link with expiry, okay? Anything more than an hour, then you'd still need to send the authorization header, but you can still do a shared access key for that. So shared access key to a client application could use a greater than hour expiry. And then you can revoke that by setting up the shared access policy as no more. And then suddenly the link doesn't work anymore. So that's a really useful tool because it allows you to have a private container that nobody can read, write, list, update, delete, etc. But you can, unlimited scale, allow, or a limited time, allow that access, right? So good to know. So recommend you use that if you can, unless you're building some sort of open service that the community should have access to and you don't really care about that stuff, right? It just depends on the sensitivity of the data and the importance to, the company and the business and the app. Okay. Still okay? Still with me? Good. I like that. So Windows Azure architecture. Let's talk about the actual application, because now we've talked about the back end mostly, including Azure Storage now and how we secure those calls, but we pulled the picture together with some more kind of thoughts on how we bring in the client applications and services. Now, in an Azure VM, you have .NET, you have code access policy, which you could limit, although I find that not very useful. We'll talk about that briefly. Your typical NT security policy, just because it happens to be a Windows box. And then you've got your web or worker role, which could actually be on separate VM, by the way, right? It's just that you can combine them now, so that's a nice feature. And your web role is typically your outward-facing applications. So you've got your ASP.NET, MVC web form sites, you've got Silverlight, and you've got your WCF web services that are publicly available as part of the app. And then your worker role is typically something behind. You could think of that as you're behind the DMZ in the cloud in some respects. You can think of it as something that actually is a Windows service that runs and pulls off a queue and does work. So there's lots of ways you can consider the use of a worker role. Okay? So ultimately, those applications and services on Azure are just .NET apps that we've deployed using the portal and or automated with PowerShell, that kind of thing. And it's going to be communicating with possibly Azure Storage, possibly SQL Azure, whatnot. So opening up the application architecture tiers, just looking at some ways we might see Windows Azure apps working with the other moving parts and some scenarios I've seen with customers. There's so many we could talk about, right? Like I'm just going to talk about a few before we talk about the security aspects. So you can have external endpoints, and external endpoints essentially mean that those are public-facing endpoints that somebody can browse to and or call openly, right? Like WCF. Irrespective of whether or not there's security on the endpoint, like how do I authenticate to the web app versus how do I authenticate to the WCF service. That's a separate discussion to come. And then we're going to have, again, our Azure Storage and possibly SQL Azure. So we're going to be communicating to our data from the web and or WCF service applications. We can have internal endpoints that put a boundary between there. It's not required, by the way, right? Because we are getting some level of, denial of service attack already provided, right, by Windows Azure. We could put the WCF service that's in the web role in the service bus and still get that DMZ layer, by the way. So this is more around if there's a good reason for you to have internal services that are never called from the outside, like you would typically have in an application architecture, you can achieve it this way, and those endpoints can't be called externally. They're also useful for management endpoints. You can build WCF services in a worker role, for example, with an internal endpoint. You call it, tell it to do a bunch of stuff. I'm not here. Just someone was on the phone. I just want to make sure, because I'm busy right now. So the internal endpoints just can't be called from anywhere else. So you can call them maybe through your application to do some sort of automatic configuration updates, or make some utility out of that, diagnostics, whatnot. So that's a possible tiered architecture, just to know there are internal endpoints and external endpoints. Okay. Now, another way to look at how we might combine this, though, my web role might have service bus endpoint on the WCF service, and that gives me my extra layer of security there. It gives me the DMZ shield. It gives me the extra authentication piece with symmetric key. It gives me the ability to do things like client callbacks, right, with my Azure service, which is interesting. And then I might combine that with some on-premise stuff, because there could always be some stuff on-premise that we just can't put in the cloud, in which case we've got the commonality of the service bus in the middle. Okay? So just one way to look at that physical tier possibility. Okay. Now, let's talk about some more practical reasons we might use pieces of the cloud, like scaling out compute cycles. So I have a number crunching application. I'm generating PDFs. I'm doing vector graphic manipulation. Anything that is heavy computational, it takes time to complete, more than just a quick second round trip, and we might need to generate a batch and get things done, right? So we usually want to somehow offload that so that it's asynchronous, of course. And then we need to maybe scale that out. I lived in environments where we needed to generate PDFs, a good example, and you could only get that down to so many seconds per PDF, and then you had to figure out how could I build 100,000 of those. Like, it took 2 weeks, right, unless you could scale out, which is kind of scary. And your customer says, well, what will be the latest I wait for that batch? Well, 2 weeks probably, maybe 3, not too long. So a web role, for example, could have a WCF service that you communicate with, and maybe that writes to a queue the job. So you're writing to one of the Azure storage queues, and that queue maybe is, again, the result of a client interacting with on-premise services that then call the WCF service to scale out. So what I'm looking at here is I have an on-premise app, but I'm using the cloud to scale out just that piece. So I've got this one service out there that I can reach. I can kick off a job, if you will. And then I get to have the worker role pick that up, pull it from the queue, and do work. Now, I could have written to the compute queue directly from my on-premise app. But then I'm exposing that and making that link available from somewhere and then managing those keys there. And I think it's a much safer proposition to have a service layer in front of that. That's a more sound architecture. It's very SOA. I could then move that whole piece of functionality on-premise later or something like that. And it's the service tier I'm moving. I'm not changing the app code internally to the other aspects of the application. So my WCF service worker role is picking up from the queue to process. And of course, the value out of that is, oops, we've got 100,000 jobs to do. Let's scale that worker role out and ask for more instances, and away we go. Again, this is not security specifically, but what it is understanding now how do I pull all this together. Therefore, there might be some other security aspects still to talk about, right? So why am I using Azure at all, essentially, is the question I'm hoping to answer. Another thing that I think is really interesting is media access. Large blobs of data, media, files, zip files, video, you name it, right? Sound. This is a really, really useful way to leverage the cloud just for that one piece, and that is something I've seen a few customers find very good use of. So we've got a client that's calling services behind the firewall. We're using the service bus to protect and give it the DMZ. And then we've got these blob containers that are going to store just the media, because I don't want to deal with the disk allocation and management of all that. And I can scale it out more quickly because I can just say, oh, we need more, right? Which hopefully means I'm making more money if I'm charging for that service. And the added benefit I get is the CDN, the Content Delivery Network, right? So now I've got URLs that will cache in the region wherever the customer lives, especially if it's a global service, and that will make faster access to that content, and then it will refresh whatever the expiry is on the cache. So this is a very, very effective way to use just one little piece of the cloud, which would be your blob storage. So given just that brief review, we've got places where SQL Azure plays, where Azure Storage plays, where the service bus is useful. And then we've got the app itself, which we can move into the cloud, and it in itself needs to be secure. So we're going to think about things like DNS attack prevention, which we get built in, right? Microsoft is going to do that for us in the Windows Azure host environment. We're going to have ACLs that prevent access to the actual VMs, which is just internal. And then there's a bunch of stuff we still have to do, but wouldn't you know, most of this is stuff I care about whether I'm in the cloud or whether I'm on-premise hosting it myself. Now I'm down to application architecture. Now I'm down to the internals of what's the best way to secure the ASP.NET app? How do I prevent issues with, CSS attacks, cross-domain calls from Silverlight? How do I deal with SQL injection? How do I deal with authentication in general? So none of this is actually new. We're not introducing anything that we wouldn't have to do anyway. There are a couple of interesting things, which I have some links for you on as well, like cross-domain call prevention. Well, if you're having a Silverlight application, then we need a way to, there's a way that you could put the cross-site scripting instruction, right, into blob storage, for example, so that it's accessible from Silverlight directly if you wanted to directly access the blob. So there's interesting things like that that maybe are a little bit different in Azure than they are on-premise because it's an Azure app. But otherwise, most of this is stuff you would have to do anyway. ASP.NET classic security stuff, right? And then we've got WCF security aspects. Probably the only limitation, which I probably should have mentioned on the previous slide, is we don't get Windows authentication out of the box, not right now. So Windows authentication, other than that, I'm basically Forms Auth and Identity Federation, which I do want to talk about. WCF, similar, right? We get our DNS attack prevention. We can certainly get the DMZ by using the service bus if need be. We're getting transfer protection the same way we always did, right? We're either using transport security with HTTPS and or TCP, or we're using message security. Partial trust, that's an interesting one because a lot of people will talk about how, isn't it great you can have partial trust in the cloud? And yeah, that's great, but I haven't written an app yet that could go up and function in partial trust because usually we're using some sort of assemblies and such that just don't work that way. So I'm not going to say that's the most important thing, and I'm not going to say it's an issue that it doesn't work because we'd have the same problem on premise, right? We still care about SQL injection. Again, parameterized queries when you write your code to call database and so forth. The thing we do get with WCF is internal endpoints behind the service bus, for example. Internal endpoints within Azure, which is the worker role thing that I was talking about earlier, that they can't be reached from outside. And then ultimately authentication. So we're kind of down to authentication now in our discussion because we've talked about how to access each piece securely, what the keys are, how to protect them, some recommendations, where the users are for SQL, for example. And now we're down to how do I secure a web app or a WCF service? Well, okay, I know I don't get Windows right now, so okay, I can live with that. But the question, maybe more importantly, rather than going through all the things you can do with WCF and ASP.NET, is why would I might consider something like Identity Federation? Because this is pretty much the de facto standard going forward for most people securing applications, and there's a good set of reasons for that. So we get to talk about things like not caring how I authenticated. Wouldn't it be great if you could write a service or an app whereby I don't care if you authenticated over there with Windows, with a username password, with a key fob, a thumbprint reader, whatever you need to do, SiteMinder. There's all kinds of two-factor authentication models out there, for example. I don't care how you authenticate it. Just send me a token from someone I trust, which is the security token service that issues the token, that does the authentication. And then I'll take that and the claims inside, and I'll use that to authorize access. So it's a really powerful model. I mean, there's nothing bad to be said about that. It's really good if your app doesn't care how you actually authenticate it. It gives you a lot of diversity to add new authentication models for different types of partners and so forth. So it also allows you to go claims-based, which is richer than just roles. Roles mean different things to different departments sometimes. Oh, well, you know what? An admin over here, I don't want them to be able to do X, Y, and Z. Can you change that? Well, now I need to create a new role or a different name for that role, or I certainly can't write code that says if you're in this role you get to do A, B, C, because now C doesn't count. So now what? If else? No. You got to use claims. You got to go more granular. You got to say, do you have the claim to write PDFs? Do you have the claim to send emails? Do you have the claim that allows you to access the customer table? And then on top of that, there's things like, well, who are you as a user? Because maybe that gives me access to only certain customers, right? Am I in the right department to access those customers? But that's more of the business logic side of things rather than the, did I get in the door? So claims-based is valuable on its own. More importantly, the IT pain of provisioning. If you have people that use multiple applications and they have accounts in different domains within the enterprise, for example, how do I manage that? How do I manage that if I want you to be able to browse to one app and go to another? You have to log in twice? No? Well, maybe there's a way to fake that by having a mapping from this user to that user. Or we make the username and passwords the same in all the tables. And then if you leave the company, how do I get you out of all the places you live now? So there's an IT pain involved with provisioning and deprovisioning users that we avoid, and a risk that we avoid. And ultimately, we want to be able to maybe add different groups of users access to the app, because maybe we've got trust with other partners or other departments or other domains at some point. So how do we add that without affecting our app? Well, we don't affect the app if we federate it, because ultimately you're just going to get the claims, and the claims are going to say what you're allowed to do, and the claims are going to say you authenticated somewhere that we trust. Where that is, my app doesn't really need to know. It just needs to know it got a token it trusts. That's it. And then ultimately single sign-on, that browser experience that we really need to have, which is I logged into app A and now I went through the portal to another app and another app and another app. I don't want to log in again. That's just silly. How do I do that? So single sign-on would be because I have trust from all those apps with the same identity provider and or same set of identity providers. Once I have a token, I'm good. So there's a few ways we can look at that architecture. Just very briefly, in case you're unfamiliar, passive federation would be the browser-based single sign-on federation, which means I am in the browser and I try to get at this Azure-hosted site, for example, and then it redirects me through the browser to the STS of whatever was configured. And then that STS says, okay, well, I don't know who you are yet, so I'm going to ask you to log in, present a login page. But that could be a lot of things, that login page. It could be I put a certificate in and IIS prompted for that. It could be SiteMinder. It could be a Windows credential, therefore I didn't see a login page. So whatever happens over there, well, I don't care, just get it done. So we authenticate, we present our credentials, and then ultimately a token is issued to the app. And that token should hopefully at least identify that I authenticated from a trusted place, but also identify some information about the things I'm allowed to do in the app, maybe. So there's the concept of identity providers, which is you authenticated. Here you go. Here's your unique identity, your name, your email, maybe some information, a UPN, a unique identifier. And then there's what are those other claims? Those other claims that are kind of important for the authorization piece. So let's defer that for a moment and kind of get to that in a later diagram. Active federation is when I have WCF services, for example, and they're hosted perhaps in Azure, and I've got a Windows client or a Silverlight client that wants to call those services, but they need to first go get a token. Well, the proxy knows how to do that, because federation binding knows I got to go get the token first, and then I can call the service. So that's sort of set up a priori. And once we have our token back from the STS, I again get those claims passed to the app, and the app says, oh, I trust that token. We've got a trust relationship. You know, it was signed with the right key. So great. Now let's take a look at those claims you got. So that's not browser-based. That's the difference. The question is, where's the STS? Well, it could be an on-premise STS written in Windows Identity Foundation if you have the desire to build one. I can help you with that. But you don't really want to do that if you can avoid it, right? It could be ADFS, which means probably you've got a domain server that's not in the DMZ, and then you've got a proxy, Federation proxy, that can call back to the domain server. That's how you protect that. And so ADFS would be the endpoint that we're hitting. And it could be, if I go back here, a Windows, well, this is going to be Windows users only, first of all, right? So this currently wouldn't work with Azure because we don't have the domain support yet except in the CTP, but it is going to be possible to do this, okay, to reach out to your ADFS. And in this case, I wouldn't have a problem even in Azure, and that's because I'm on a Windows client, so my machine's probably on the domain anyway, which means it works out. Whereas if I'm doing browser-based, then I would have the issue for the redirection. Now, there is access control. So enter the other feature in App Fabric that we should talk about, which is your STS, your identity, well, not an identity provider, but an STS in the cloud. It gives you the same federation capability. There's a couple unique capabilities that make it kind of interesting for some people, and that is, for example, I browse to the app, I get redirected to access control as the STS I trust to get a token from. And then that can give me access automatically to any of these well-known providers. So if I have community users, social networking users that I'd like to support in my app, if I'm building that type of service, I get that for free now. That's awesome. A lot of people want that. So I get to not have to write any code. I get to say, oh, we're going to support Google, Facebook, Yahoo, blah, blah, blah. I can customize the login page. It'll redirect. The user will get their credential of choice. They choose which one they want. Maybe we set that as a profile preference. And now what's happening is I'm getting a token back, and that token will be transformed. You're going to put some rules in there that say, perhaps we're going to pass through the claims you got out of Google or Facebook or Windows Live and so on, but we're also going to add maybe some other claims that make sense. So if you came out of Google, I might pass some other indicator, you know, that says you're a community user. There's not a lot much else I can do with community users because I don't get enough information out of that identity provider to tell me what role should I put you in. You pretty much probably live in one role if you came out of there, and that is you're a community user and you authenticated at Google or Windows Live. I can probably know that. And then otherwise, I get this unique identifier for that user that I can put in my system. And then I can create a profile for them in the system that says what are they allowed to do. So they might have to provide a license key or something to augment the authentication process so that next time they log in, I know what they're really allowed to do. You can make that happen. So that token that I ultimately get is going to carry whatever we transformed inside access control. But access control can, and so yeah, so all we care about is that token. I forgot about the bouncy circles. That's a failed demo too, right? Because I forgot about the bouncy circle. Oh, damn. Okay, so the browser, if you're authenticating possibly not to these community identity providers, might redirect you also to an enterprise identity provider, which could be ADFS behind your corporate firewall, or it could be some other. So the idea is that any STS that supports WS Federation, WS Trust can be there. Ping identity, so on. So we're going to get a token back, but now the token is going to carry a little bit more interesting stuff, isn't it? Because it's going to say maybe what department I was in over there in that domain. Maybe I'm in marketing. Maybe I'm in something else. Now I can say, hey, if you're in marketing from that domain, we're going to give you, this type of permission set. You can create, read, and update, but you can't delete. See what I mean? So you can start kind of manipulating the claims a little bit so that access control ultimately returns us more useful information about who you are and what you did. But the value prop here is that I can add other providers and scale that out. I can add partners and not affect. But let me show you a model I see a little bit more of. Rather than using just access control, because there's other things we might need to address, like non-Windows users. So ADFS, for example, or we need a user store, credential store, SQL. So what I see more of is we have this relying party STS, something you have on-premise perhaps, or maybe you host it in Azure. And that relying party has maybe users in a SQL database. And so I can actually authenticate there when I'm redirected. But if you belong in ADFS because you're within a certain IP range, and I've done this with many customers, then in that case, we redirect you to ADFS. And if you are in the community and you want to authenticate that way and get lesser rights in the system, then guess what? We can pop you over there too. So that will allow us to, through access control, get for free all the networking providers, or the social networking identity providers, and then also any other identity provider from trusted partners out there, other companies outside our firewall. And then the people behind the firewall come in through either our custom credential store and or ADFS. What's really cool about this model, though, is that, number one, we only trust one type of token, always, from the STS, the STS that we trust. We're always trusting that token. But also we get a chance to have maybe some richer policy governance around who's allowed to do what, and manage that across applications, and have that policy transform the claims inside the STS that we own. So we can put more business logic in there, more business rules around the claims, which is an interesting model. So we get to kind of combine this whole picture. So that's what I'm typically seeing. Okay. Now, how you doing? Whew. Did you learn anything today? I hope so. Do you have any questions that you might want to stay after and talk to me? I'll hang out after. So let me wrap this up for you and just say, first of all, thank you for coming. Second of all, just remember that you have to define the application architecture before you look at the security and where I'm putting stuff in the cloud and which things can go in the cloud, right? This is all important. You have to do that risk assessment with the business first, right? And that risk assessment is really around, can I put data in the cloud and what are our concerns, right? The heavy concerns from the business side. And then ultimately, you now know how to secure each and every piece because we've talked about that. So that's good, I think. And from there, it comes down to structuring the application architecture and the internals of the application and how you might need to do claims, for example, if you're doing identity federation. So I love to get questions on that. You should definitely email if you're doing claims-based stuff because it's easy for me to answer those things, and I have tons of code samples on my site, but even more that might not be posted, so always ask me. And also on Azure, and also related to this topic, just kind of covering the developer needs in you, which I know some of you have as well. So with that, I hope that you have a great rest of your tech ed, and I'll be around here right now for questions, and then I guess I'll see you around the TLC labs after. So have a great day, and do not forget to do your evals. It's really, really, really important that you do that. Thank you. Okay.